Namaste and good morning, everyone. I'm Dr. Sandeep Shah, Associate Professor in the Department of Anatomy at PP Kara Institute of Health Science, Nepal. My topic of presentation is Introduction to Kidney Stereology. As you know, the uniferous tubules, they are the important functional unit of the kidney. The glomerulus is main filtering unit of the kidney, which helps for the filtration of the waste product from the blood and maintain the osmolarity in the homeostasis. The reduction in the total number of the glomerulus as well as the surface area is very important for the different renal pathology. Stereology is the mathematical study that applies the formula of mathematics. The three-dimensional information of the biological structure can be estimated from two-dimensional by having the slices with the help of the stereological technique. As we already mentioned the importance of the stereology in the renal pathology, the quantitative analysis is very important in basis for the glomerular number, size, filtration, surface area, and the different cellular composition of the glomerulus. The different steps are there for the stereological technique. The first step is the tissue sampling, where we use the smooth fractionator method for the kidney sampling. We approach the fixed kidney, which is decapsulated first. The fixed kidney is done with emulsion-based technique or the perfusion fixed technique. Then we have to cut the half along with the coronal section, and we can maintain the longitudinal and transverse plane, keeping the plane at which the kidneys are cut with a constant within a particular study. Figure 1 is showing the example of the smooth fractionator sampling technique for the renal research. You can see at the beginning of the random piece, every 9 pieces is then selected to achieve the final representative sample up to 8 to 10 pieces of tissue per kidney. Sampling fractions at each interval or the level of the sampling are recorded as shown in the figure 1, as these are needed for determination of the kidney volume according to the different types of the study. The kidney volume is mainly estimated with the principle of point counting method based on the Cavalieri principle with the help of the whole sized kidney or after tissue processing using stent section. The determination of the kidney volume in the kidney slices is done with the help of the transparent sheet with the printed orthogonal grid of size 4 mm by 4 mm over the sample size according to location of the kidney, for example in the medulla and the cortex. Using the whole slices is very important, having the advantage of least time consuming, and it maintains the hydration without shrinkage. The only disadvantage is it is not accurate precisely. Whereas the determination of kidney volume in the kidney section is the alternative, mainly done is sampled and the embedded resins, preferably done in the glycobutyrate resin rather than the paraffin due to the less tissue shrinkage. The number of the glomerular number or the number of the glomerulus is important uh, for the neurogenesis, which is the excellent indicator of the impact of the environmental and genetic changes during the gestation and the kidney development. The progression or the extent of renal disease can also be monitored or determined by assessing the nephroglomerulus. The total number of the glomerulus within the kidney is determined by the physical dissector or fractionator approach, which is shown in the figure. Figure number 1, by no curve section on the beam. We can see the two lines, mainly the red edges, which is the extruded lines where the particles are not counted, where the particles intersecting the green edges and are in the middle of the unbiased counting frame are counted. So this is how the number is counted by using the physical dissector. Functional capacity of the kidney, whether or not the process of compensatory hypertrophy is occurring in response to the low number of nephrons or in any diseases. The mean renal corpuscle volume for kidney is then calculated by dividing the volume density of the renal corpuscle by the numerical density of the renal corpuscle in the kidney. Again, the length of the glomerular capillary and the surface area is very important to have the knowledge of the functional capacity of the kidney, mainly dependent upon the total renal filtration surface area, also known as TRFSA, which is a product of the average capillary surface area per glomerulus and total number of functional glomeruli in the kidney. We can also use the alternatively the projected microscope, which projected onto a printed grid on the white paper on the tabletop. So this figure number 4 is showing the TRFSA of the kidney estimated by multiplying the average total surface area of the capillaries for glomerulus in the kidney by total number of the glomeruli in the kidney. The image of 1 micrometer torrential blue stain section of the renal corpuscle from the newborn sheep kidney overlaid within the orthogonal grid. So this is how the TRFSA can be calculated with the help of the grid. The various stereological sampling strategy applied in the kidney tissues of the different animal types is tabulated in this table, where you can see that we got in the different resources and the kidney parameters. There are measures like the kidney volume, total glomerular number, the total glomerular number in the different species, like in the pig, cat, the renal cortex volume, the renal medulla volume, glomerular volume, and the total glomerular number in the different species can be usually done by the different method, like the physical fractionator, like capillary method, and for each author the stated the coefficient of error value was sufficient in the article which is stated in the table. The future of the renal stereology is the use of the various frames, lines, cycloids, and points named as the probe could be frequently applied in the future study, since it looks the evaluating the physiological structure by those probes seems to be a user-friendly in terms of the recent advances in the technology. The figure 5 is showing the representative image of the immunolevel glomerulus from the inner cortical area of the kidney, which is mainly stained by the Davy stain. In conclusion, the counting of the renal glomeruli has been performed for more than 100 years by means of the different principles. Essential hypertension, chronic kidney disease, and the renal transplant are associated directly with an endowment of the nephrons. A dissector basically counts the sample particle in proportion to their frequency in the 3D spaces. Both the shape and the sizes of the particle is not influenced by such estimates. The workload in the sampling can be minimized by the help of the modern stereology along with the derived and the quantitative information on the structure of interest. These are my references. I would like to acknowledge the Professor Dr. Suleiman Captain for giving me this wonderful uh, platform for the presentation in the 4th Asian and the African Stereology Congress. And I would also like to thank the organizing committee and all the organizing chairman and the team for giving me this platform to present my topic in the international congress like 4th Asian and African Stereology Congress. Thank you very much.